Hello everyone. I'm going to talk about timer IC255 applications. So in previous we have discussed about astable mode applications. So especially for LED display devices, we are using astable mode applications. So in this regard, I'm going to talk about a few of the applications used in monostable mode. Missing pulse director, linear ramp generator, frequency divider, pulse width modulation. So these are all the essential factor which will be useful in the circuit if the circuit has found any mistakes. So these are all the four remedies for identify the mistakes of the corresponding circuit. So that I'm just taking as these four applications in monostable mode. So first one is missing pulse generator. So every frequency have a lot of signals. Every frequency has been generated by using a cycle, positive and negative cycles. Some of the frequency may not be generated in a corresponding frequency range. At the time, we are going to find we are going to analyze the concerned frequency. So that type of frequency can be identified by using this missing pulse detector. So this missing pulse detector can be identified by using the capacitor and resistor and the concerned transistor. So based on the output, we can able to find which pulse may not occur in the concerned frequency range. So it can be calculated by using one formula T equal to 1.1 into R into C. If the triggering pulse has exceeded in the time signal T equal to 1.1 into RC, then the signal may not appear in the concerned frequency range, so that we can able to identify in the output signal. So this type of pulse detector can be missing pulse detector can be useful, very useful in a large number of frequency generation. And second one is we are going to find a linear ramp generator. So in this linear ramp generator, if you keep on continuing the generation of signal, sometime we may have to execute some large number of signals. At the time it will be very useful. So here the transistor and capacitor has been connected in a series. The capacitor has been generate the voltage based on the response received from a transistor. So initially, transistor voltage can be calculated by a constant voltage source. The constant voltage can be followed by using a constant IC current value. IC equal to I equal to V by R. So VCC minus VE divided by R resistor value RE, and then VE emitter voltage can be calculated with respect to the resistor terminals which are connecting across the terminals, and it will be calculated by using the above formula V equal to R2 by R1 plus R2 into supply voltage plus base emitter voltage. And then after the concerned voltage has been applied to the capacitor, so that we can able to find the concerned executed pulse. So the executed pulses has been formed as a slope. So the slope is calculated by I by C, current by capacitor. And the next one is frequency divider. So in this case, we are going to calculate the how much number of the frequency has been executed in the output signal. We have to check whether the frequency has the concerned frequency has same in the input as well as the output. It can be followed by resistor and capacitor. Initially the capacitor has been discharged with respect to the threshold value. After that it will be connected in the resistor, and the resistor R1 and C1. If the resistor R1 and C1 has taken as a proper one, then it will generate a cycle. The cycle is given as input in input signal. Then the input signal is given as a frequency in the n number of frequencies. That frequency will be identified, and that frequency can be calculated in the output. If the output is same, then the input is matched with the help of the resistor and capacitor. If the frequency is not matched in the output signal, then the frequency and the corresponding numbers will be identified in the above circuit. Next one is pulse width modulation. So in this pulse width modulation, there are a lot of pulses has been executed in a different time intervals. That time interval has been calculated by using this pulse width modulation, especially for if you are giving input signal as a sine waveform. Sometime we can able to catch some high pulse and low pulses. So these kind of pulses has been used for low voltage and high voltage purpose. Suppose if you want to add more number of signals in LED, if you want more signals in LED, at the time it will be very useful. Or if the motor has been running in a very speed or very low speed, at the time this pulse width modulation is very useful to use in such kind of applications. So these are all the applications using monostable multivibrators. Thank you.